Welcome to qnawire.
This problem is number 32 in Chapter 8 of the Chemistry, Structure, and Properties textbook, second edition by Tro. And the problem or question is as follows. To what volume should you dilute 25 milliliters of a 10 molar sulfuric acid solution to obtain a 0.150 molar sulfuric acid solution? So to begin, this is a dilution problem. So we are going to need the dilution equation. This can be found in this textbook on page 323 at the top, and is equation 8.1. The equation is as follows. That's M1V1 equals M2V2. So let's begin by first breaking down our variables. So M is for molarity, which is a unit or a measure of concentration in units of moles per liter. V is for volume. For this specific equation, the units of volume do not typically matter, but they're usually in either liters or milliliters. As a side note, your teachers or professors may also write the equation like this using variables instead of numbers, so I and F. I is for initial or what you start with, and that is the same thing as 1 in the above equation. F is for final, where you end up, where you end, and that is the same thing as 2 in our first equation up here. So let's go ahead and read the problem and see what we're given and what we need to solve for. So, to what volume should you dilute 25 milliliters, so that's a volume, of a 10 molar, okay, that's molarity, concentration, sulfuric acid solution to obtain a 0.150 molar, that's another molarity, solution. So if we're going to obtain this one, this is where we're going to end. This is our final. This is our initial. And if we're diluting it, it must be our stock solution. What we're starting with, M1, goes with V1. When we read this to begin with, there were some context clues to what volume should you dilute, which would have let us know that we were looking for V2, but it's also fine to do that at the end. So now that we have our variables, we know what they mean, their units, and the values, we can go ahead and start this problem. So again, this is our equation. And we know that we're looking for V2. So we can go ahead and isolate V2 now by dividing both sides of the equation by M2 and getting our final equation here. And now this becomes, at this point, a plug and chug problem. So we can substitute our values. So if you recall, M1 was 10.0 molar. We're going to bring over all of our digits and our units, because at the end, we are then going to need to evaluate our sig figs and our units for the final answer. Okay, V1 is 25 milliliters. M2, if you recall, is 0.150 molar. And we're looking for V2. So if we just do our numerical answer first and just put this into our calculator, we find that V2 comes out to be 1,666.6, and that's a repeating decimal. Now let's go ahead and first evaluate our units. So we've got molarity times milliliters over units of molarity. Molarity divided by molarity leaves us with units of milliliters. So that'll be in our final answer, which I'll write over here. And then if we remember our rules of sig figs from chapter 1, we know that for multiplication and division, the rules are the same in that we are limited by the limiting number of sig figs. So if we just count them up, we have 1, 2, 3 sig figs in this number, 2 sig figs in that 25 milliliters, and 1, 2, 3 and 0.150 molar. So we're limited by the 2 sig figs and 25. So that's what's going to dictate how many sig figs are in our answer. So we're going to start from the left, and we're having 1 sig fig, 2. So this is the number that we're going to round. And that ends up being 1,700 milliliters. So this is the final volume that we would have for our answer. And your teacher, your professor may or may not ask you to convert that to liters. If they do, it's a pretty quick conversion. I'll just do over to the side here. So this is where we're starting. And to change our units, we always want to make our answer a fraction. We're going to put where we are at the bottom and where we want to go at the top. And we know there are 1,000 milliliters for every 1 liter. Again, we can get rid of our units there. Milliliters will cancel with milliliters, and 1,700 divided by 1,000 is 1.7. And again, this answer is in liters. And that's how you would do that.